In this video, we're going to take a closer look at ion-dipole interactions. These are the attraction between an ion and the complementary end of a permanent molecular dipole. Let's take a look at an example. Here's formaldehyde. You've got the hydrogen, carbon, hydrogen. The carbon is double bonded to an oxygen. This molecule is polar. This charge map shows the green end where there's less electron density and the red end of the molecule that has more electron density. For a detailed breakdown of where this polarity and this dipole moment come from, check out my video on dipole interactions. Let's look at how this molecule could interact with ions. If it interacts with a cation, the cation is going to form an attraction to the more negatively charged end of the formaldehyde. This is because electrostatically, positive and negative charges attract. If, on the other hand, we have an anion that's interacting, that anion, being negatively charged, will prefer to interact with the slightly positively charged end of the formaldehyde. A very common example of this phenomenon is the sphere of hydration. This is the cluster of water molecules that forms around a dissolved ion. If the ion is an anion, then you can see that we form these ion-dipole interactions between the anion and the hydrogen parts of the water molecule. That's because these are the slightly more positively charged portion of the molecule. If it's a cation in solution, then that cation will form interactions with the oxygens, and most specifically the lone pairs on those oxygens because they are negatively charged. Ion-dipole forces are stronger for stronger ions, for instance, a +2 charge versus a +1 charge, or for stronger dipoles. That's because the greater the difference there is between the electrostatic charges, the stronger the interaction is between them. Go check out my other videos on intermolecular forces, but otherwise I'll see you in class.